Hello friends, Sagar here. I once again welcome you to my YouTube channel Physics with Sagar. This is the lecture number 2 for the chapter Communication System. In previous lecture, I covered the introduction part of this communication system chapter and the elements of communication system, with including the basic terms we are using in this communication system chapter. So before starting the video, I have a small announcement for you. Like, you may be knowing this announcement which is made by government for this situation of COVID-19. Due to this situation of COVID-19, many classes of this academic year 2020 and 2021 have been missed, which is a huge loss for the academic year. So to compensate that loss, the government has decided to reduce the syllabus by 30% for the classes 9th, 10th, 11th and 12th. So I have collected the reduced syllabus of CBSE board for the class 12th. I will be putting the link of PDF in the description box, so please check out. So let's move into the video. So for our first topic is bandwidth of signals. As I told you in the previous chapter, what is signals? Signal is the information which is converted into electric form so that it is suitable for the propagation from transmitter. So you know what is the signal, but there are different types of signal like speech, sound, video, etc. etc. So for transmission of those different signals, the different frequency, that is bandwidth, is there. So in this topic, that is bandwidth of signal, we will see what is the bandwidth for different things. So bandwidth, first of all, speech. The frequency range for the speech, the range is from 300 Hz to 3100 Hz. What is the bandwidth of speech? The bandwidth is calculated by subtracting the higher frequency range minus the lower frequency limit, so which will be 2800 Hz. Our next type of signal is sound. As you know, the audible range of sound is 20 Hz to 20 kilohertz. So this is the frequency range for the sound. So you know how to calculate the bandwidth. So please calculate the bandwidth and comment in the comment section. The last type of signal is video. Frequency range is very high. It is from 4.2 megahertz to 6 megahertz. So please calculate the bandwidth and comment me in the comment box. So this is all about bandwidth of signal. So the next topic is bandwidth of transmission medium. Before starting the topic, I would request you to subscribe my channel and hit the like button if you have enjoyed the video till here. So in this topic, that is bandwidth of transmission medium, we will see what is the frequency range or the bandwidth for the medium through which the signals transmit. Like, you know that the signals transmit from one point to the another point. This signals need some medium to transmit from one place to another place. So that this medium also has some frequency range within which this signal can transmit from here to here. So in this topic we will see only the frequency range of the transmission medium. There are totally three types of media. One is wire, second one is free space, and the last one is optical fiber. I will tell you the frequency range for each by taking an example for each type of media. For wire media, you know the coaxial cables which require 750 megahertz of frequency. And the next type is free space. Free space means there is no physical connection between the transmitter and the receiver. There is the transmission of signal through space, through the atmosphere. So the example is radio waves, the FM radios you listen in your car, in your home, etc. etc. This type of free space transmission medium requires the frequency range between few hundred of kilohertz to few megahertz. Is optical fiber. This optical fiber needs 1 terahertz to 1000 terahertz of frequency for the transmission. Our next topic is propagation of EM waves, that is electromagnetic waves. But now the question arises that how does this signal propagate from one place to another? There are totally three types. One is ground wave propagation. Next one is sky wave propagation. And the last one is space wave propagation. Let's start with the first type, that is ground wave. Ground wave. In this, I will explain you by taking a diagram. This is your earth surface, okay? This is a transmitter antenna and this is a receiver antenna. Now the waves will go on the ground surface itself. The signals will only move on the surface of the ground and reach the receiver. There are two types of propagation of any type of wave. They can move vertically like this, or they can move horizontally. Now in this type of transmission, this type of propagation, the waves propagate in vertical manner. The frequency range for this ground wave is 540 kilohertz to 1600 kilohertz. So you know the frequency range for this type of propagation. Now see, this is transmitter antenna and this is receiver antenna, which is placed on the ground surface, on the surface of the earth. Okay. Now as I told, in this is transmitter and this is the receiver antenna. In this, the waves will propagate in vertical manner, and the frequency is very less if you compare the frequency range in sky wave or space wave. Now, as this is moving, that was all about ground wave propagation. Ground wave propagation is also known as surface wave propagation, as the propagation takes place on the surface of the earth. Moving ahead, our next type of propagation is sky wave propagation. In this, the propagation takes place in the atmosphere. That means if this is the surface of the earth and this is transmitting antenna and this is a receiver antenna, the EM waves which moves in the space, they get reflected from one type of layer and then gets to the receiver. That layer is called as ionosphere. Why ionosphere? Why that layer is named as ionosphere? You may have heard the term ionization. That means if there is an atom and it gets energy from any type of source, if we give energy to that, the outermost electron, the valence shell electron, the electron which is in the outer shell of that atom, gets excited and ejects out, to which that atoms get ionized. That atom is known as ionized atom. So, in the similar way, you know that there are many molecules, there are thousands, there are millions of molecules in our atmosphere. So they also get energy from sun. Sun is the biggest source of energy, as we all know. So the layer that is ionosphere, the molecules in that layer gets energy from the sun and then they get ionized. So that layer is known as ionosphere. Now you know how the ionosphere is formed. It is formed by getting energy from the sun and get the electrons, the atoms get, or the molecules get ionized. So the ionosphere layer is made. But you may have a doubt, why not the layer above the ionosphere is ionized? Because there are also molecules in above the ionosphere. See, if it is a ionosphere, okay, this is a ionosphere, and there are a layer below the ionosphere also, and the layer are also above the ionosphere. Now what happens? The density of molecules gets decreased when you go on the upper heights, above the ground level. See, if this ionosphere has 1,000 number of molecules, then this layer will have 100 and this will have 10. This will get more energy, obviously. The sun is here, it will get more energy, but there are less number of molecules. Because of that, there is less ionization. Now, leave this ionosphere, come down. As the sunlight, the UV rays, the energy form comes down, the energy is very less because of the absorption of energy by these layers. So the temperature, the energy is absorbed by the layers above the layers of ionosphere. So you get very less amount of, this has 10,000, okay. This layer below the layer of ionosphere has more number compared to ionosphere, but the energy which it gets is lesser than this. There should be a balance between the energy and the number of molecules, which is exactly peaked in the ionosphere. So ionosphere is the best layer from where the EM waves can reflect. So this is the surface, antenna, transmitter antenna, receiver antenna, ionosphere. The ionosphere are being subdivided in other types of layer within it. So now you should firstly know the range. What is the range for sky wave propagation? The range is from 3 megahertz to 30 megahertz. Okay. Now if the frequency range is less than 3 megahertz, then what will happen? The waves will move but will be absorbed by this layer, the initial layer of ionosphere. Okay. If the frequency range is 20, okay, the waves will penetrate through the first layer of ionosphere, but it will be reflected from the second layer of ionosphere. Okay. If the frequency is less, it will travel less distance. If the frequency range is 30, okay, it will move far. It will go to the last layer of ionosphere and then it will get reflected and will move for more distance. But what if the frequency range exceeds 30 megahertz? Now you see, if the frequency range exceeds 30 megahertz, it will penetrate through the ionosphere and will get into the space, so that the frequency range is 3 megahertz to 30 megahertz. The next topic is space wave. This is the most important type of propagation. Mostly the numerical part is from this topic only, that is space wave. In this I will make a clean diagram. So this is the diagram. If you can't understand this diagram, you can refer your textbook. I have referred the same diagram from the textbook, or I have made some little changes. So I will explain what are the terms in this. The first term is dt. This is the distance from transmitter. Distance traveled from transmitter means how much distance the waves traveled from the transmitter. Next term is, this is transmitter antenna. Okay. Next term is ht. This is the height of the transmitter antenna. Height of the transmitter antenna. Next term is re. This is the radius of earth. Radius of earth, which is approximately 6400 kilometer. You will take this same value in your numericals. You will apply the same value for the radius of earth in your exams for the numericals. Many times it is given. If not, please remember that. The next term is dr. This is the distance traveled, or the distance till where the receiver can collect the waves. So this is the distance from receiver antenna. My handwriting is very bad for this video because I am not feeling that well, and I am recording this video at night. That is, the time is 11:30 now. Receiver antenna. The next term is hr, that is height of the receiver antenna. This is all about the diagram. A, B, C. See, this is the Earth surface. Okay. This is the transmitter antenna and this is the receiver antenna. In space wave propagation, the propagation takes place only in the straight line. Okay, the propagation takes place only in the straight line. In this space wave, these are used for LOS type of communication, that is line of sight. Line of sight is the distance between the two antennas by which they can see each other. That means if this is the transmitter antenna and this is the receiver antenna, this distance in which these both can see each other is known as LOS, that is line of sight. These antennas are built so long, so high from the ground level, because as you know that these waves travel in straight line, propagate in straight line. So this bend, this curvature should not interrupt the waves which are going. So therefore the height of the antennas are very high. Now, as you can see, this is 90 degree. So by applying Pythagoras theorem, we can calculate the distance traveled by the EM waves from the transmitter. So let's calculate in triangle ABC. AB square plus BC square is equals to AC square. Now what is your AC? AC is your DT, that is DT square plus what is your BC? Your BC is the radius, that is the radius, sorry, the A is your height from here, okay. So your BC is the radius of Earth, that is RE square, and your AC is the radius of Earth plus the height of the antenna. So that is RE plus HT the whole square. Now here you can apply A plus B whole square, that is A plus B whole square is equals to A square plus B square plus 2AB. Okay, so this is DT square plus RE square equals to RE square plus HT square plus 2REHT. Now as you can see that the radius of Earth is very much greater than the height of your transmitter and receiver. So you can neglect this value. You can neglect the value of height of the transmitter. So this is the equation will become DT square plus RE square equals to RE square plus 2REHT. Okay, this RE square and this RE square gets cancelled. Now what remains? That is DT square is equals to 2REHT. By this you can calculate DT equals to under root 2REHT. Similarly, if you take this here A, then you can also calculate the DR similarly, that will be DR equals to, please try to calculate DR by your own. This will be the same way by which you will be calculating DR. So DR will be under root 2REHR. Okay. Now we have to calculate the total distance traveled by the waves. That will be dn equals to dt plus dr. That is nothing but under root 2re ht plus under root 2re hr. Propagation of waves takes place of the waves which have the frequency greater than 440 megahertz. Any waves having frequency greater than 40 megahertz, that comes under space wave propagation. So here I end today's lecture. So please support me, stay home, stay safe, and please do study for your knowledge, not for marks. If you have any query, any doubt related to this video, please DM me, and I am putting my WhatsApp number in the description box. Please, if you have any doubts, you can contact me personally out there. Thank you.